All right, welcome back, everyone. This is day 2 of cybersecurity with Python and the microbit. With you today are me, Andy Lindsay, Stephanie Lindsay, and Ari Alvarez of Parallax. This is the July 26th installment, 2023. If you are following along, especially after the fact, after the video, I have a bit.ly link for you to make it easy to enter into the computer. Otherwise, for those of you who are here, I'll send this to you from the chat in case you want to look at a previous slide while I'm on a different one. As with the Monday session, I encourage you, I don't know if my thumbnail is currently obscuring it for some of you, but there should be in the upper right-hand corner of your Zoom screen, and this is for if you have a single computer screen, you can hit view and then exit full screen. And then after that, you can tile the presentation side by side with your microbit Python editor. Oh, okay. Speaking of side-by-side tiling, this is something I recommend for learning the material, both for you and your students, especially if you're new to Python. It's going to be important to treat these web pages that I've been talking about like they're a textbook, because they are in fact a textbook. So to show you how that works, I'll go to learn.parallax.com and tile it side by side with the Python editor. Okay, so here we are with learn.parallax.com in one window, and then the python.microbit.org/v/3, i.e. microbit Python editor in the other screen. And I'm going to make the simulator go away to free up some room for seeing the code. And then in the learn.parallax.com, treating it like a textbook, yeah, you can go to cybersecurity. I'm going to go to Cyberbot since it's really a superset of all this material. And then the cybersecurity, the microbit only cybersecurity, well, I'll open them both. So here is the Cyberbot tutorial series. And then here is the cybersecurity tutorial series. And with the Cyberbot tutorial series, you'll see a lot of the same stuff, because what we did was we peeled away cybersecurity components. So the prerequisites are very similar. There's no converting to a cyberbot, as an example. And then the main lessons, instead of focusing on your cyberbot robot, they start with radio basics. So here is radio basics after you've finished the cyberbot robot basic navigation and sensor navigation stuff. So then it goes into radio basics. We start immediately at radio basics after going through the computer science lessons that we talked about on Monday. And I think that the thing I really want to emphasize is that these are all chapter headings. And so you'll end up looking at a chapter, for example, the writing microbit programs chapter, which is in both, really focuses, it's a chapter about the basics of Python programming. And then coming after that, I went very quickly through computer microbit talk, dictionaries, exception handling, strings and characters, and there was a lot of material that I kind of just touched on Monday. And one thing I want to say about that is that if you're feeling like, wow, this is too much, I'm supposed to know it. No, you're not necessarily supposed to know it, especially if you're new to Python. And so, but during a 6-hour workshop, really all there's time for in many cases is for me to show you this is what this is, as opposed to this is everything about how it works. As another example, if we were spending 6 hours talking about biology or chemistry, I might talk briefly about the periodic table and how it's important to learning chemistry, but then I'll end up having to move on. We can't all memorize the periodic table and be ready to start talking about which ions combine with which others. Or if it was biology, binomial nomenclature would be something that I would just touch on briefly and say, okay, it's a chapter on binomial nomenclature, and we'd be talking about it on this week during the course. And so yeah, some of the stuff that I went through on Monday, I just touched on it, but I want to emphasize that since these are chapter covers here, you can go through, especially if you're new to Python, and learn all about it. So starting with writing microbit programs, here we are at the chapter cover. And then I'll go back. So back here we are at the chapter cover of writing microbit programs. And so you can read about the overview of the chapter. And then the first example is talking about the LED matrix on the microbit. And then I know this one's familiar because everybody did it for homework before coming to the course. But as a student, or as a teacher who's learning Python, from my own experience as an engineer, I'd like to share with you that I had to go through and learn Python very quickly because I got pulled into the Cyberbot Robot project at certain points. And so I did a lot of this in order to be able to code at the level that I needed to code to get the project to completion. And so I essentially do this myself. I'll basically actually read through. I'll read all about scrolling and what it is, and find out that there's a display.scroll method that we're going to use, and that quotation marks and parentheses are involved. And oh, here is an example of scrolling. And so I'll actually in my Python editor, I'll actually type in the whole thing from microbit. And then it makes suggestions of what you could fill in. And it's kind of nice because you can actually stop and read about what it has to say about this. And, so right off the bat, we notice that this example is given in single or double quotes, and this example here is given inside single quotes. And so that's going to raise a flag for me. And so as I try out the code, I might try it out this way first, and then I might try it out with single quotes and find out that it still works, because either one defines a string in Python. We find out later. They have a how it works section, and I'll read through that. And then what they're doing now is adding a feature and having me try it out. So I'll type it in again. And the typing in the code is really a good thing. In addition to reading, in addition to hearing about it from your teacher, it's going to be the kind of thing that helps a deeper level of understanding of all the scripting concepts that students are going to have to demonstrate some competency with. And since this is a chapter, once you're done with one page, you have a next page and a previous page, pardon me, and a next page button. And so this basically takes you to the next page with more concepts being introduced, more examples, et cetera, et cetera. And so I had everybody try out just little pieces. The very first example from each activity in the chapter. So here's the chapter, and it's split up into activities. So LED matrix and displaying is one activity. Variables is another activity. Math and operators, conditionals. These are all activities that students go through, and some of them are more than one page, while others are just a single page. But regardless, each one is a tutorial. It has a number of things that students can discover along the way. And whenever possible, get them to type it in or give them some challenges. So we have a try this where there's a little snippet. And I believe that's for a modified version for what we have up here. And then there's a your turn where they're challenging the students to do something on their own. And that will encourage them to put their hands on the keyboard and start experimenting if things hadn't occurred to them while they're typing it in, or if they copied and pasted. But for all of you, and if you're teaching middle school, treating this as a textbook for learning MicroPython would be kind of a good thing. If you're going to try to introduce Python at the middle school level, it does not hurt to learn it at the high school level. And then I've spoken with many teachers that have taken this material, especially for the Cyberbot, and essentially taken pieces of this and then made them into worksheets that are handed out, and then the students go through the simplified version after the teachers have kind of decided what their students need to see. So that's a little thing about learning and how much information there is here. This is as I said, this is a full textbook. Each of these are chapters. Each chapter is split up into multiple activities, and then again, the cybersecurity is peeled off of the larger Cyberbot robot list of tutorials. One last thing I want to say about that is that going through setup and testing and up through writing microbit programs, well, if you're using the Cyberbot, you'll also want this add modules to your microbit, and you can learn more about that in the Cyberbot workshop, which I'll be talking about briefly. Then what happens is in these Cyberbot lessons, they reinforce and show practical applications of mostly stuff in writing microbit programs. Then the cybersecurity area shows applications of and reinforces some of the stuff that I went through quickly during the second hour of Monday, that being dictionary primer, exception handling, and etc. And again, these are all chapters. Each chapter has activities. If you go through it step by step, you're going to learn Python pretty well. And then we're always here to answer questions for the teachers. All right. So that was a little bit about that. And then I said I was going to talk about the Cyberbot workshop. We have one coming up on September 18th, and I'm going to share that link, a link to the events calendar with you. So here it comes in your chat. And if you have a more general computer, if it's not specifically cybersecurity that's your goal, if you have more computer science and hands-on stuff that you want your students to do, possibly even some tech ed concepts, the Cyberbot robot is going to be a good possibility, something that's definitely worth trying out for you. And it also will kind of help complete the picture of what students learn, because right now we've got basics in cybersecurity, and the Cyberbot will do basics, and then how those basics are applied to navigation with the Cyberbot robot. And the students get to do a little bit of sensor circuit building and some other fun stuff as well. So that's coming up on September 18th through the 22nd. It's going to be every other day, Monday, Wednesday, Friday, 3 p.m., just like this one is. And there are still openings. It closes on Friday. So if you want to fill out the request for this course, definitely do that soon because we're closing the course. So you can go here to, let's see, I pasted it in, yes. And then just simply view event, you can read about it, and then do the application down here. And it's very similar to the one you filled out to go to this workshop. For middle school resources, I'm going to just very briefly touch on, we usually talk about the cyber.org stuff on Friday. I'm going to briefly talk about it today, several different topics. The first is that cyber.org has teacher resources for a number of topics. They really emphasize cybersecurity, but they also have some additional cyberbot resources and some other courses that you might find to be of interest. It's a free resource to teachers. It's NSF funded, and so they're generating curricular resources for you. And if you're a teacher in the United States, you can sign up if you're not already part of that. And we'll have that be part of the homework along with signing up for the parallax.com free resources. And so I'll show you just a little thing. So this is, I'd better back up one. So once you've signed into cyber.org, these are their classes. And these classes are set up quite differently from what Parallax has on the web. First of all, this is a teacher-only area that we're looking at right now. And what I wanted to bring to your attention, especially for those of you middle school teachers, is they have a coding fundamentals class for the microbit. And this is currently kind of a middle school targeted class. And you have the option of using Make Code Block for much younger kids or Python. Since we've been talking a lot about Python, let's take a look at Python. The lessons are actually almost identical for Python and for Make Code Block. And so they're going through graphics and the display and buttons and conditionals. And then they go into the compass, which is something that we don't really do. So in some cases, there will be nice additional lessons that you can find here. The lessons are somewhat different. For example, if we look at the teacher notes, let me see which one. I think I looked at compass right before the session started. Well, let's look at buttons and conditionals. So here's the teacher notes, and it's going to be a download. There's a worksheet that's handed out to the students, and then they share the source code with you. All right, so looking at all of those things. Okay, so first off, this is their teacher notes. And so they go through the need to know stuff for you and basically kind of give you a primer on what to talk to the students about. Here's the worksheet for the students that you would be printing and sharing with them. And then this is source code that they have held back here. It might be something where you're showing it to them, or it might be something where you're sharing it to them. So these are resources that they supply for kind of lighter level, more basic lessons. And then going back to the courses, I backed out of it too far. Let's see here. Here we are. Okay, so back to coding fundamentals. They also have a cybersecurity section. And in here, they have it split up. Like, let's take a look at denial of service. So here's a denial of service attack. And again, they have teacher notes, and in this case, a presentation. And so instead of putting notes inside the presentation, what they do is they have the teacher notes separately. So here is the presentation that you'd be going through with the students. And it's very methodical about what to do and how to do it and what script to use. And again, this is not something that you're necessarily sharing the students. It's sharing with the students as a file. It's something that you are, doing your slides, doing a PowerPoint, showing them the PowerPoint. And then additionally, they have the teacher notes that accompany that. And so this is what's talking about. This is where it's going through essentially what to talk about during the slide. And then they have some scripts. This is the source code that you would be showing them. And again, for those of you who are new to Python, I went to the tail end of the course here. So don't worry if it looks like a long program by the time you get here, or a long script. By the time you get here, you'll understand what it's all about. And there is some of the lessons will be the same because some of our material was underwritten by cyber.org. And so we tried to stay in line with some of their lessons with our lessons. And so another thing is that by looking at their material and looking at our material, you'll have two different takes on, in many cases, the same stuff, but you'll also have some extras going, Parallax will have some extras that they don't necessarily have, and vice versa. Well, I think I'll leave the rest for Friday on that. And next up is what we're doing today. We're still in questions, answers, and review. And I'm just going to go as far into cybersecurity attacks and defenses as I can. We'll talk about some encryption stuff and some brute force. Your homework will primarily be to sign up for the teacher resources that Parallax makes available if you have not already. If you have already signed up for those resources, we'll just want you to make sure that you're good with your password and getting into the teacher resources area. I'll talk about that near the end, but I want to emphasize there that it's not required for any of the hands-on stuff. So don't worry if there's any kind of hiccup or got you getting into the resources by Friday. And that'll be the same with signing up for cyber.org. Just get the process started. I recommend using your teacher email address because then they can look you up in the district files and verify that you're a teacher without having to ask you for any additional proof. For those of you who would be signing up with us, we're just going to send you an email letting you know that we've added you because you've already been vetted by us. And then on Friday, we'll try to pick up on whatever we haven't gotten to. That'll probably be malformed packets and defenses. I'll talk a little bit more about some of the cyber.org stuff. Then we'll go over Parallax Educator resources, which is why we're hoping you'll all be able to log in. But again, it's not required for participation. I'll just be doing some showing stuff with it. Yes. Hello. I think we need somebody to mute themselves, and maybe
I think it was Carol and she just did.
Okay. Poor Carol. Sorry about that. Carol, if you use some earbuds or some headphones, it might prevent that feedback thing from going on.
Also, if you have a question, you can put it on the chat and we can pass it to Andy too.
Yes. Either way is highly encouraged.
I'm using more than one computer. That's what's happening.
Okay, so I can tell you the trick there. What you want to do is mute. I actually have a second computer too. And what I did was there's usually a key where you can mute its speakers. And then you can also mute the mic input. So yeah, you'll probably see a second Andy Lindsay computer, and that's how I'm managing to not have any feedback when I speak. All right, let's see here.
Okay, I did have a question.
Yes, go ahead.
I moved over to, I've got Zoom on a different computer here.
Okay.
What about in all the registrations and stuff like that? I don't have those kind of teaching credentials because I teach adults with the Seattle Robotics Society. So how would I?
So for cyber.org, I don't know if cyber.org, I believe their mission is K through 12, and they are probably audited and have to support only those teachers. We, however, can make a judgment call. So we'll get you into our teacher resources at the very least. And then you can, write cyber.org an email. If some of your students are not adults, then that may apply. Like if you have some students who have not yet graduated from high school but are taking classes from you, that would be an argument that could be made.
Yeah, sometimes the parents will bring their kids for the classes.
Yep. So
I have a
that's
mixture.
yeah, because I know that one community college teacher from a previous class also had a program where they offered credit to where their adjacent high school would come and take some of the classes at the community college level. And so they let her in based on that info. So that's a thing to try. Don't sweat it though if you can't get in. You can have our teacher resources because we trust you. You're good.
Yeah, the only kids I really teach are, there's a church group that has me teach a course in robotics every year.
I see. Okay. Well, yeah, you can leave it up to them. Give it a try or not. It's not for you. I don't think it's overly for your particular setup. I don't know that it's going to be that beneficial. So yeah. Okay, good. But yeah, if you're not already in our teacher resources, we can set you up, and that'll be there'll be some additional things there that you might find useful for teaching the adult classes that you're teaching, worksheets and the like, basically assessment materials.
Yeah.
Okay. So here's the review part. So for radio basics, what I want to do is go back and the first thing is going to be, I'll copy the, so for homework, we did bidirectional texts. And again, bidirectional texts is I don't know how you want to look at it. You could either look at it as the second activity, or it looks like we've done quite a bit here. There's been sending radio messages, receiving, talking about how messages work, and then here we are in texting with terminals. So there's several pages that have been covered before we got here, but this is one that is kind of a centerpiece of some of the lessons. Okay. And so did I share the chat, or did I share in the chat? Paste there. Okay. So this was one that we did for homework, and I also want to use it as a warm-up. So I'll go there myself. Close these other pages. And oh no, I think I might have pasted you guys the wrong thing by accident. I might have pasted you unidirectional texts. I'm pasting bidirectional texts now. And so the script was right here, and we'll want to run this script and make sure it's working so that we can do some of the other activities. So let's see here. I'll paste you in this script And then we'll want to make sure that both our microbits are connected. I left mine intentionally disconnected so that we can go over those steps. So the first thing is, since we're going to connect 2 microbits, which again is not something that students are going to do in the classroom, it's just something that we're doing as teachers attending the online workshop. So I'm going to make sure that I've got 2 microbit Python editor tabs open in my Chrome browser. And then going over to my microbits, I need to plug them in. I'm off screen adjusting the brightness. There we go. All right. So yeah, step 1 is going to be plugging into the USB. And there we go. And they're running scripts from last time. Then we need to connect to each microbit. And so to do that, basically you only need to connect once. And then after that, as long as your microbit is still connected over USB, one microbit will automatically receive the program from the script you have going in one tab. And then another microbit will automatically receive a script that you're loading from another tab. So seeing how this works, and again, this is just because we're all in the workshop as opposed to students with individual computers. You hit the 3 dots next to send to microbit and select connect. And then the Python editor will give you a choice of 2 different microbits. And it's good to make a note of which one you're choosing. Like, for example, on this left tab, I want the one that ends in 200,000 here, or ends with a 2 to be the one in the left tab. So I'll select that and click connect. Or if you just wanted to select the top one for the left tab and then go to the second tab and select the bottom one, that's fine too. I'm going to select 2000 for this tab. And then go to the other tab. And when I hit the 3 dots and then select connect, I just want to make sure to select the other microbit. So that was the one. So I selected the one with 200,000 ending. And this time I'll select the one with the 300,000 ending. And then confirm that I want to connect to it. And so now one microbit is tied to this editor, and the other microbit is tied to the other editor. So if I go to this tab and hit send a microbit, looks like this is the one connected to the left tab. So I'm actually going to sort them accordingly. And then the other one should be this blue one, which will start displaying hello. There we go. All right. So hopefully you've got all that ready. And then the next thing to do would be I copied and pasted in the script into your chat window. And select all, paste. And you want to do this for both microbits. Send them, click send to microbit on both of them. And then in both editors also, I'll put these guys side by side for a second, because this activity has you working almost entirely in the serial terminal. And basically just type something. And it should appear in the other microbit because this microbit sent it out its radio. This microbit received it, forwarded it to the computer, and then you see the response here. And then you can say I. So we want to make sure that that works.
We are getting notices that people are not seeing the script.
Okay, let me paste it in again. I hope that's what is meant by not seeing the script. There it is. And I'll paste the web address that it came from as well.
Where are you pasting it?
Into the chat. And so to look at the chat, if you are...
I'm not seeing it in the chat.
Okay, let me open it up on my attendee computer. You know what? Somebody probably chatted me directly. Yes. Whoopsie. Okay, I've been chatting everything to one person for some amount of time. Let me try that again. Thank you. Okay, do you see it now? Did it come through?
No.
Okay, one more time. Paste.
There we go.
Oh, good. Thank you, Stephanie.
You're welcome.
And also, if I forget to move my boom mic around and start sounding really quiet, please let me know. I noticed that it was over by the microbits, even though I was talking at the computer screen again.
We could still hear you. You just sounded like you were in a can.
Okay, yeah, that sounds about right. Okay, so that's a warm up, and this is an example that is pretty well into the book, but it's a fun one. Students really like it, and some of you may find yourself, if you're doing a condensed version of a cybersecurity treatment, you may find yourself skipping a lot of material to get to this, and that's something that's going to be on a class by class basis, how you decide to teach it. The beautiful thing is that this is unencrypted. Everybody can see it. And so it gives a first look at the fundamental challenge that the internet poses when trying to conduct commerce over it, of the need for encryption and the need for privacy. After the radio basics chapter, there is a radio data chapter. And in this one, you might recall that we did hopefully everybody did this as homework, so we'll just do it real quickly here. Because I do want to point out a couple of things about this script. So there's a sender and a receiver script, and what you'll want to do, let me just, I'm going to paste the web address for this script, and then just bear with me for a second. You've got the address where these scripts are, and I'll show you, I think, the best way to do this. I apologize, my computer for some reason keeps snapping back to the presentation screen. So I'm pasting the address that I just pasted into the chat, and this application is the countdown application. But what the students are going to do, and what we're going to do, is we are going to split the countdown timer up. It's kind of like if you set a timer in your phone and then your watch is the one that has the alarm go off. This is kind of an example of that, where in one tab, we'll paste in the sending script, and then in the other tab, we'll copy and paste in the receiver script. And I'll point out a couple of things in these scripts. And then basically run both of the scripts. And it's probably best to run the receiver script first, send to microbit. And then I'm going to come over to the sender script. And when I run that, it should give me some prompts in the serial terminal, in the serial console, pardon me. And so what it's saying is to enter the countdown start. So I'll say 4. And then what's the message after countdown? Kaboom. And then I almost hit send to microbit. Once you hit enter, what's going to happen is you'll want to go over, and lo and behold, in the other terminal, I think it's probably better if I put them side by side for this. I'm going to do this one more time. So I'll send the sender script to microbit. Okay, so 3, go with an exclamation point. And then when I hit enter over on the right side, that's where it does the countdown. So on the left side, the sender would be like your phone, configuring your watch to go off at a certain time. And then if you have, for those of you who have smartwatches, that's one of the nice features they have. And then over here in the receiver, they're actually doing the script. And so this is step 1 of taking a fundamental application script. So previously with the chat, that's a communication script. This is an application script. It does a job for you, the countdown timer. And so unlike just straight communication where strings are getting sent back and forth, with this, it's actually sending a dictionary across the airwaves. You might recall from dictionaries that they have a key and a value. So after is the key and its value is go, because that's what I typed in. And then 3 is the value corresponding to start. And so what happens is, and again, this is not something that you need to understand inside out until going through the book, possibly keeping just a few activities ahead of your students. That's happened to me before. This part right here was first talked about in the dictionaries chapter, and now we're applying it. We're actually assembling a dictionary that has some data. And again, dictionaries are similar to the JSON data that is communicated back and forth on the internet. And in fact, we have a web application called the Cyberscope. It's a voltmeter and an oscilloscope and some other measuring tools. And we even use, this same approach with that device. And that's part of our electronics curriculum, which I'll talk about on Friday briefly. Then it gets sent across the airwaves. It gets packaged as a string, gets sent across the airwaves. On this side, if radio packet is not none, I should change that. It's a awfully double negative way to do it. I think I'd rather say if packet, but sorry about the double negative there. It prints what was received in the packet. So the packet went out like this. And that is also the way it came in. And with the receiver, just like a server and a client, if a client sends a packet to a server or vice versa, they have to take it and pull it apart and find what's in it. And so basically, this is a statement that students learn that eval is a way to take a string and turn it into whatever Python thing, in this case, a dictionary. So it came in as a string, and eval is what makes it into a dictionary, and then we're just giving it the name dictionary. And then after that, value this is the way dictionary of start will get us the number 3. And message equals dictionary of after will get us the characters GO in a string. And then it does the same countdown that the students did and became familiar with in an earlier lesson. So hopefully that that helped out with a few things about the hows and whys of that particular homework assignment.
We have a question. It looks like when the packet was printed, it printed the after first and then started second. Why?
Oh, what a great question. That is discussed. Let me see if, well, oh gosh, I don't know exactly where that's discussed. So I'm going to tell you the answer, and I'll keep my eye open for it, because it would be nice to show you that we actually talk about that in the book. Very nice catch. I'll just do this again too, and hope it, I'll use the same values. So 3, no, whoops, 3 and go. Yeah, so are they in a different order? No, they're not in a different order necessarily, but it seems like I entered this first. So it seems like it ought to be the first thing in the dictionary. But the key thing about dictionaries is that doesn't matter, because whenever I give it a value, it's going to be paired with the key start. Whenever I give it a message, it's going to be paired with the key after. And so then over here, when I come and ask for it, when it needs the value, it says, give me the value that corresponds to the key start. Well, that's the number 3. Does not matter at all where it is in the dictionary. And that's one of the beautiful things about dictionaries, is that you don't have to be stuck with making sure that the 5th element is always filled with the number 3 and the 4th element is filled with go and that kind of stuff. It just makes everything much more natural. Just give me the value that corresponds with a key that has this name. And of course, that's why industry has come to rely on JSON packets, which again are like dictionaries, or which are essentially dictionaries, but, you know, sent across the web. And Stephanie, if you happen to see it, also paste us a link to it. Let me see if I can find. I'll just take a second to look for where that's discussed. I know it should be really close here. Ah, try this, out of order. So we have an entire little activity where the students are, well, it's the try this. And so they are discovering hands-on that the order does not matter. All right, so that takes us through our homework. If there are any other questions, you can unmute and shout it out or type it into the chat. Either way, I'm going to move on and do a quick intro of encryption. So that is the next thing up. So essentially, we're setting a groundwork for cybersecurity by, first of all, setting up a radio network with the microbit. I really should go back and just talk about the microbit radio. The reason the microbit has a radio with the idea, it's a low energy Bluetooth radio, and the chip, the microcontroller, has that Bluetooth built into it. And what Nordic Semiconductor, the manufacturer of this chip, has done is that they've added an alternate protocol, which is called the Gazelle protocol. And that's probably back on this page. So we talk about the, yes, the Nordic Gazelle protocol is talked about right here. And it's an alternative to Bluetooth. With Bluetooth, you have to pair it with another device, and then you're kind of stuck just communicating with that device. It is good for, if you're using a tablet to load code into a microbit, you can do it over Bluetooth, and that's great, but it makes it kind of difficult to do the cybersecurity exercises because they use a different protocol and they need access to that radio, and it probably won't work if you're tied up with a Bluetooth pairing to another device. So we use the physical USB cable to load the scripts, and that frees up the radio so we can do this networking stuff. And we now have networking down. We've got communication, sending text back and forth. And then we've also got sending data packets back and forth and learning how they work. So now one more foundation before going into cybersecurity is going to be encryption. And we use some really basic stuff that hopefully the students can wrap their mind around. Namely, we start with the Caesar cipher. And the Caesar cipher was, my understanding is that it's named after Julius Caesar because that's what his troops used to keep their messages secret. And with the Caesar cipher, this is a little diagram that, let's see, is there a length of message on texting? Yes, there is. Really good question. I'll jump back to that. See how it says length equals 50 there? There's a certain number of characters that you might run out of, or that are used for internal data. So I think that like 2, 3, or 4 characters, like you can only, if you say the buffer length is 50, you can use 40 some odd of those characters for your message. The maximum buffer size, I think, is 254. Somewhere in that neighborhood, maybe a little less, but yeah, from memory, it's 254. I'll do an off-screen quick search here in Google, microbit radio buffer. The send buffer is, no. Okay, let's try. Oh, 200, up to 251 bytes. Okay, so this is in, okay, so what I did was I used Google, but you could also just hit the question mark in your editor, go to MicroPython documentation, and then find the radio section. And this may not be the one. Let's see, 251. Okay, so this is the student level introduction, but there is also a developer level introduction further down where they talk about the radio API. And here it explains that it's up to 251 bytes. Excellent question. Thank you. All right, back to the Caesar cipher. All the trick is, if you're doing it by hand, is if you want to send an H as the H in your hello message, what you can do is you can jump over by some number, and that number would be your key. So 1, 2, 3, 4, 5. So H is really M. And then E becomes J. And LLO is QQT. Again, that's if your key is 5. If it was 6, H would become N, and so on and so forth. Now, there is a special case, which is when you're counting characters, if you start with X and your key is 5, you'll want to wrap around and end up with C as your ciphertext. So your plain text, if it's X, your ciphertext after the key is applied would be C. I hope those I hope these nice little illustrations are helpful. There's also cyber.org has a neat little thing with 2 dials that are stacked on top of each other. So you can, and they have the alphabet around it. And when you rotate it, you can see, if you rotate it by 5 letters, then you would see H immediately lines up with M and that kind of stuff. We were thinking about possibly a printed version too. Okay, so then there's encrypting a single letter. It's kind of just not all that exciting because it's a script where you have hard coded the M and you get to see what comes out. After that, there's the how it works. And what that goes into, there was a lesson, a bunch of string lessons in the strings chapter that the students went through where they learned how to say, oh, you know, let's look at the 17th character in the string. And, you know, what is that? So if you have an alphabet, well, the 17th character is a P. Well, you can add 5 to that and get a new value. I'm sorry. Yeah. So if we start with M, which is the 12th letter in the alphabet, and then we add 5 to it using some of the tricks that were learned in the string chapter. And again, don't worry about that as you're going over it more gradually, step by step, a few classes or ahead of your students or during summer, you'll have the full foundation for this. And so what this is showing is, okay, alpha.find of the letter M gives you back the number 12. So you know you're starting at the 12th character in the alphabet. Then that gets written to index. So we started with M and we ended up with the number 12. Then we said, okay, to apply the Caesar cipher, index equals index plus key, which is 5. And so now our new index is 17. And then we can go and get the 17th letter, and that's an R. And so that's actually at the low level, one way of doing the Caesar cipher in a script. And so that's the how it works part. And it even goes into the modulus operator, which is essentially, hopefully everybody remembers long division, where, you know, if you divide 4 into 9, you get a result of 2 with a remainder of 1. Well, in this case, if you divide 24 into 6, the result is 0, but the remainder is 24. And if you divide 27 or 28 or 29 into 26, well, 26 goes into 29 once, but the remainder is 3. And what that does is, going back a page, what that does is that remainder causes you to step 3 into the next. That's the whole how to use a script to wrap around when you're doing the Caesar cipher, is that there's an operator for taking the remainder of a division problem. And by using that, you always get the right value out of your Caesar cipher. So let's try this. We'll encrypt and decrypt with terminal. I think I want, oh, actually it's break time. Sorry. After break, we will go ahead and try a a Caesar cipher script with our terminal. It's currently 2 past the hour. So if you could all come back at 9 past the hour, we will reconvene then.
Before I pause the recording, I just want to let people know you do not have to email us to request an account at learn.parallax.com for Parallax's educator resources. I've already created the accounts for you and will be sending login information after this meeting today. If you're interested in the information at cyber.org, you will need to request an account over there.
Yeah, and on that, if you go to cyber.org, basically there's a sign up link right on their homepage. And so that's what you'd be going to. And remember to give them your teacher email address so that they can vet you before letting you in. Welcome back, everyone. So we talked about how the Caesar cipher works. And so what we'll do next is encrypt and decrypt with the terminal. And so this is a little bit, again, we're well into the chapter already. So we've already done 2 activities, one that's a multi-part. And so now we're encrypting and decrypting with the terminal. We're also many chapters into the book at this point. And so here is our page with the encryption example. Now this is this is not a radio one. This is just for 1 microbit. And so what I'll have you do is go to learn.parallax.com and then grab the Caesar terminal words script. So here I am at learn.parallax.com. I'm going to put that web address and go to it. And then here we have the script of interest. And again, this is going to be one for the terminal, and you can do it in either of your microbit tabs. What I'm going to do is use 1 microbit tab just to show the script, which you don't have to worry about. And then I'll leave the terminal open in the other microbit tab and paste it in and send it to that microbit and start responding to the prompts. So it's going to prompt you enter a key. Well, if we want to see, just for our own edification, that HELLO really is MJQQT, we'll want to use the number 5. Now, tricky thing though, we'll want to also make sure to use capital letters. So capital HELLO. And there is our MJQQT. And I don't know if this particular script is able to deal with lowercase. Oh yeah, it says set your keyboard to caps lock. So I'm assuming that there's not exception handling for lowercase. So let's try lowercase hello and see if it breaks. It does break. But that gives the students an opportunity to see an example of why just to help users exception handling can be useful. Of course, there's also a clever little string trick they learned in string about making everything uppercase for you. And so the next one I'd like you to try is Caesar ciphers in a function. So I'm going to paste that address in. Oops, what did I do? There we go. And this one has a little feature added to it that will prevent that crash from happening. I'll go ahead and paste the script in. and then paste it into my so I just want to stick with what we know here. So I can type capital hello. We get our MJQQT. But if I do lowercase, because of the fact that from the strings chapter, we're using the letter dot upper method. When I say hello now, it crashes. I didn't think it would. Okay, I might not have loaded the, I might not have done the right script because now it is working. So hello in all caps. Oh, I'm guessing that it wants the key each time. And maybe that's what I did wrong because I'm not reading the instructions. And shame on me, I didn't quite prepare well enough because obviously I didn't catch this. Enter key 5. Hello. Okay, it says enter key again, and I missed that. So I need to enter 5 again. And if I type a lowercase hello, it does not break. So there are more ways than just exception handling to address user errors, which is worth noting. Okie dokie. Folks, have you been able to get that to work? Can I get some thumbs up? Okay, very good. Very good. Thank you for confirmations oh, I love it. Perfect. Okay. All right, so this does go further into other kinds of ciphers. So I just really want to mention that we talk about different kinds of ciphers. Like the next step up is to take the ASCII character, because every key on your keyboard, and there are 94 of them, have these character codes. Like capital A is 65, capital B is 66, and so, or maybe capital A is 64, pardon me. Learn.parallax.com. ASCII codes, ASCII table. It's linked earlier. It just wasn't linked on that particular page, so I had to go hunting for it. And capital A is ASCII code 65. Lowercase a is ASCII code 97. And of course, they go up from there. But there's a whole lot of printable characters, starting with the space bar, and then going through some of your special characters and numbers, and then ending with the tilde. And so if you take all those printable characters, you can have a little bit more, it's a slight increase of robustness. And then it talks further about what are called shift ciphers. And I can't remember if at this point we talk about a custom cryptobit or if we just do a reverse alphabet. It looks like, okay, here's the ASCII shift cipher again. Okay, coming up in brute force. Oh, substitution ciphers. Okay, so now, yeah, now is where where we talk about, okay, you can do more than just jump over a number of characters like the Caesar cipher. Like here's a variation where you have an alphabet that you're using, and then a cryptobit that you have to use for conversion. And this one has the name @bash cipher, and it is just simply a reverse alphabet, which is another one that was used in ancient times. And but you can also use a custom cryptobit. In fact, using like in this example, I believe this covers everything you would need to make sure that you can support your countdown time and whatever message comes after your countdown time. Though I'm thinking that this exclamation point might actually throw a little bit of a hiccup into this, because I'm not seeing it in the alphabet. So when you make a cryptobit, if you use an exclamation point, it won't work. Although it's a great experience for students to have, it was not something I intended. So Stephanie, any chance you could send me a quick email reminding me to to fix that problem? And so that covers an intro to encryption, albeit at a very basic level. We're not going into, 256-bit encryption and all that. For the microbit, that would be overkill at this point. Also, the microbit's onboard resources, it's going to be difficult to do some of those ciphers. There are, if you program in Python on a computer, it's easy enough to import a cipher library. If you're doing it with the microbit, those libraries are really large, so you can't really import it into the microbit. Cyber.org does have a little cipher library for the microbit that has some other ciphers, and it's kind of nice because then your source code is not doing the grunt work up front. It's kind of tucked away, and you just say, I want the Caesar cipher of this, or I want the Pigpen cipher of this, and it goes ahead and just gives you the encrypted result. And that's kind of a nice thing. And again, we'll talk more about cyber.org resources on Friday, along with Parallax resources, and I'll try to remember to show you that. Okay, so now that students have the encryption down, they are now equipped to deal with several different kinds of cyber attacks. The first one would be the sniffing attack, where they're just being listened to. And so what I'd like you to do, and this one is actually better with a group of 3 students, and so you'd want to have 3 microbits, but I think we can just we can all think about this first as a student, and then as the intended receiver student, and then as the sniffing attacking student. So I'll give you this. So we're on to the next chapter here. Paste. And so this example is sending happy, sad, and angry over and over again, just as an example of sharing something personal. And so there's a transmitter script and a receiver script. Now this time you will see stuff in the terminal, but you'll also see the happy, sad, and angry faces on the microbit. So go ahead and grab the scripts from these pages and put one in your sender microbit and another in your receiver microbit. So I'll copy the transmitter. Oops. I'll go over to my workspace here. Okay, so here's the transmitter script. We'll put that into one microbit. and then the receiver script into the other microbit, and then load them both. So send to microbit, other tab, send to microbit. And then if we show serial on both, looks like I just lost temporarily my microbit connection. Came back, that's good. All right, so here's the transmitting microbit, and it's sending the different faces. And then the receiver microbit is receiving those faces. Again, this is happening over the radio, where we have a transmitter, but it's unencrypted and anybody can see that information. So taking a look at our microbits now, this is the transmitter microbit. Looks like I've swapped my tabs on my editor, so I'll just go ahead and swap the tabs on this is the transmitter microbit. And then here is the receiver microbit, and the receiver microbit is both displaying its received value here in its serial terminal and here on the LED matrix display. And the reason for that is because it's doing two different things. It's saying print receive comma packet, where packet is what it receives from the radio.
They were having a
And-
little trouble hearing you. Could you bring the boom
Oh,
around?
thank you so much, Stephanie. Yeah, there
Thank
goes the boom mic. I will get that habit, I promise. Yeah, so here we have packet, which is whatever the result of radio receive is. And then it basically says, well, if a packet came in, which thankfully doesn't have the double negative, then it prints the packet. And with a print statement, it ends up in the serial console. Immediately after printing, it uses display.show along with a clever bit of code that is explained in the how it works section. Basically, when you start with text for happy, sad, or angry, get attribute is a function that will take that text from packet and plop it into the image. And so that is a way that that is how it converts what it received to something that the microbit can display on its 7-segment, or pardon me, on its 5x5 LED matrix display. And I think that because I have the lights on today, we're getting a little bit of interference with the microbit, so that's why it's hard to see the entire face all at once. But you can kind of see there's the angry face, here's the happy face, and the sad face. And give me a shout out if any of you can't get that to work. And so the main thing that this chapter brings up is that, okay, your second microbit that is receiving all this could be the intended receiver, or it could be the sniffer. Then this is the how it works. And as I mentioned, it explains this get attribute in here. Then for the try this, the idea is to, bear with me a second. We're not encrypting it yet. Okay, So for the try this, they're sharing custom images. So this is hearkening back to custom images, which was part of the programming basics, although not part that you did as homework, but part that I'm hoping you'll end up encountering if you go through it in more detail after the workshop. Now moving on to share something personal encrypted. Here we are sending out those same faces, but encrypted, and it's actually going to crash the sniffing application, which is kind of nice. And so what I would like you to do, although this is for 3 students, what I'd like you to do is first try the transmit and the receive to make sure it's working. And then, oh, I'm sorry. Okay, bear with me a second. What we're going to do is we are going to assume right now that that this microbit here is our sniffer microbit. And what we'll do is we'll change from unencrypted to encrypted data on our transmitter microbit. That should crash our sniffing microbit. Then we'll update the script to in this microbit to be the intended receiver microbit that is decrypting and has the key, and it'll use the Caesar cipher. So remember, just update the transmitter script first. In fact, I'll paste it to you. Hopefully, I don't know if it might be too big. Nope. Okay, so just update your transmitter script first, and then hopefully that'll cause an error, an exception to occur, an unhandled exception to occur with your receiver microbit. So you want to find the one that says send, and then we'll select all, paste, and send to microbit, and then switch over to your receiver, which is supposed to be the sniffer, and you'll see that it immediately crashed because it could not, it has a script that's converting happy, sad, or angry to things that the microbit understands, but it does not have a image that corresponds to KDSSB. So it failed. So, so the other ones repeatedly sending different images, but the receiver microbit has stopped in its tracks, the sniffing microbit. Now we'll update the sniffing microbit, and now we'll imagine that we're the student that's the intended receiver.
We have a question.
I'm not
I
surprised.
don't think we'll be a happy answer. How do you know if you are being sniffed?
Oh, well, yeah, there's no real happy answer to that. Oftentimes you find out the hard way when your bank account empties, or unexpectedly, or in real life, or on your microbit, if somebody knows that you sent sent a particular message, and you find out that they know that you sent that message.
Is the radio waves, we have a comment. Since it is radio, I don't think you can, because once you send out the signal, it's pretty much ambient. So all you can do is make the signal unintelligible to everyone but your intended recipients.
Exactly, which is essentially the way the internet is as well. It's essentially an open channel, and everything is happening in the open, but since it's strongly encrypted, folks don't really have any motivation to try to figure out what those packets mean. And so now I have pasted and run the intended receiver script in my second microbit, and we can see that it is now receiving encrypted values and then decrypting them. And and then correctly displaying the image again. Now, difficult for us, but cyber attackers can end up being a wily lot. And so, so they might end up figuring out pretty quickly that by displaying by trying to display the message on their microbit, even though it's encrypted, it's crashing their microbit. And so they might actually take out or comment that statement. So it's not displaying on their microbit anymore. And then suddenly the sniffer can see the encrypted data stream, and they may even figure out, well, gee, sad has 3 letters. So this must be saying sad. And they can even work back to figure out the key.
We have another
And-
question. Did
yes.
you give the code for the receiver?
Oh, I'm sorry. I probably didn't.
Because I distracted you with the question.
Thanks for taking the fall for me, Stephanie. Okay. Copy and paste. I'll also paste the page now where that was. Yeah, this is it. Okay, so there's the page that we're working from as well. Okay. And that, oh, yeah, so just one quick thing is that after learning this, there is also texting encryption and decryption, which I think is really worth trying, because this is something that the students' interest will hopefully become more keen about. So this is going to take me a second, actually, because what I want to do is have us start with the unencrypted on both microbits, and then switch one over to encrypted and then the other over to encrypted. So I've got to go back to radio basics, bidirectional texts. Okay, so we'll have you go back to this where you are running it in both microbit modules. This is from back from what we did at the end of the day, and then redid on homework and at the beginning of this this session. Is I just pasted it into the chat. So we want both microbits going unencrypted initially. Control A, Control V. Send a microbit, send a microbit. Show serial, show serial. This is unencrypted. Can you see it? I'm a sniffer, and I can see it. Something like that. And then if you're switch the roles of your microbit, you can say, I'm the intended receiver, and I can see it too. And if you were to change your radio's buffer up here to length equals 251 on both ends, you could actually type some really verbose messages instead of the short ones. Notice I was splitting my sentences up into more than one line. I'm just going to leave it at an even 250. And you don't have to do that, but it is something that you could do. this probably would have been split up before. So make sure that you've got that going, and give me a shout out or text Stephanie to tell me to slow down. And then what we're going to do is one by one, switch over to encrypted. And this encrypted, I'm thinking it's going to be too long to paste into the chat. So we'll have you go and grab the encrypted. And remember, first, I want you to just run it on 1 microbit. So grab the encrypted text from this page that I just, oh, thank you for the thumbs up, everyone. Grab the encrypted text from the page I just pasted in. It's only a little ways down, and run that with just 1 microbit. And then try repeating the chat. Show serial, show serial. Okay, so you'll have to enter a key on the chat where you, the 1 microbit where you loaded the chat. It's going to ask you for a key just so we can see everything. I know it's more fun to go nuts with the keys, but I'm going to try to keep everything familiar so that we can verify some certain things. So like if I type hello in all caps and hit enter, we get our familiar MJQQT on the other side. So that is what we hope our sniffer will see, although it gives the sniffer quite the hint in order to guess our key. So instead, maybe I'll type goodbye. And it's this is actually using the ASCII version of the Caesar cipher, where all 94 keys are being used.
We do have some commentary on the last lesson with just the Caesar. I was thinking a good classroom activity would be to have the students work as pairs and choose different radio channels and or use different keys. They can also change the plus key in the index defined to a minus key to make the one that decodes it.
Yes, and I think actually we have most of that in the activity. Again, since time is so limited, I'm sorry I can't take you through every little bit. Let me see. I'm nearly positive we have, using different keys. We do assign students different channels usually. Let me make sure we're doing that here. Oh, wait, wrong one. Okay. So, usually we talk about splitting off onto your own channel. I don't remember if we do that here. Yeah, I'll take that and make sure that we've got that material if we don't, because we really should. And I thought I put that in here, because normally I tell them to split off onto their own radio channel, and we actually split the groups up. Like if you have I forget how many radio channels there are. I'm pretty sure it's in the 80s. And so if you have a class of 20, then you can split up radio channels. Okay, your channel 0, your channel 4, your channel, or well, actually then you have 10 pairs. So it can be your channel 0, your channel 8, your channel 16, and so on. And normally the instructions tell the students to split off onto their own channel so they can do this. And actually in this case, we'd be doing a group of 3. Now, did I, okay, so then, so thank you for mentioning that. It's in the chat and I'll try to take a look because I think we've got everything you suggested, but on the fly, I don't want to take the time to try to find all of it or not. So sorry about that. Anyway, the next step would be to paste the intended receiver script into the other microbit. Now that we've seen what the sniffer sees. Oh, so I'm using the key 5. So now the receiver needs to know that they're using the key 5. And so instead of seeing the ciphertext, the receiver is now seeing the plain text that was transmitted across the radio waves, which is fundamentally like the internet in that it's open and anybody can see what's going across just about. And so now it's being transmitted in secret. Okay, everybody got that working? I'm not seeing an instant bunch of thumbs up. I better give you all some time. Okay, 1 worked great, thank you. 2. Well, 2 gave me a thumbs up. Let's just move on. Just kidding. I've had that happen to me so many times. I'm scrambling to get caught up. So do go ahead and click that reactions. Yeah, hit the reactions button and give me a thumbs up once you got it going. Thank you, Gilbert. Thank you, Susanna. Oh, wait, maybe that's Donovan. Let's see. Sorry. Donovan, Elaine, good. And Chiani, hope I got that right. Eric. So again, the goal is to have both of those, both and some thumbs. Oh, sorry, I wasn't looking at the chat. Thank you for the thumbs ups in the chats. I think we're getting pretty close to where we can move on to the next topic. And we'll just touch on it because it's getting close to the end of the session. So next up, that was an example of sniffing. And next up is brute force attacks. And as an introduction, I took a picture of a lock that Stephanie, while watching probably Longmire or Sherlock, we found a bunch of our old combination locks, and she spent the time while watching some cool TV shows to brute force attack all of our combination locks where we couldn't remember the combo anymore. And so that is an example of brute force, is trying to figure out a key by using all the different combinations. And brute force looks at it from a few different angles. We talk about how it's used to encrypt flash drives. And then the German Enigma machine, and how there was a very large machine that performed a brute force attack And I'm trying to remember its name, the bomb machine, ending in an E. And then what we do is demonstrate how to type a binary pin. And so this is first just the working version of the binary pin. And so there's a pin transmitter and a pin receiver. And I'm going to show you guys first how this works. Okay, so I'm going to copy the transmitter and go to my transmitter microbit and oops, and just send it to the microbit. Then we'll go back and grab the receiver. Just keep watching for a second, and then I'll have you do this on your own. Okay, so I'm going to copy Control A, Control V to paste it into my receiver, send to microbit. Okay, and then now with my transmitter, okay. So with my transmitter, I can press the A button to select a 1 or a 0. So that's a 1. And then just one dot is a 0. So I'll type in 1 1 or 1 0 1. And as soon as I type that third digit, I got an X on the second microbit. And then so then we can look at what is the real code that we want, and the correct pin is 0 1 1. And so if we go back and type 0 1 1, we should get a check mark 0. So I don't have to hit the A key to change it to 1. I can just hit the B key to advance to the next digit, and then 1. And when I hit the B key again, it's going to advance to a copy of the previous digit I entered. So now it's good. And when I hit the B a third time, I should see a check mark in my receiver microbit, and that's the correct pin entered. All right, so I'm going to give you this page now and have you try that out. You'll have the transmitter script and the receiver script to load into your respective microbits.
Donovan made a point that with all of these, the key makes a difference, and having students try different keys to show that the wrong key doesn't work, and without the correct key, it will not be deciphered.
Oh, so well said. I wish I could say stuff like that. Thank you, Donovan. Keep the comments coming, please. Okay, so you now have your the page where it's showing the receiver, and yes, do try an incorrect pin and then the correct pin, and then give me a thumbs up when you're ready to move on. Meanwhile, I'm going to make sure that I've got the encryption version ready for you. Oh, yeah, so we're going to do a brute force attack next. So what I'll do is I better let you make sure that that's working first. And then we're going to replace the transmitter microbit script with a brute force attack script that figures out the pin. Thank you for the thumbs up, Carol E. And Alex. Sorry, I wasn't looking there for a sec. Donovan, nice. Sheila, good job. Jennifer, John, well done. I'm remembering to now check both the chat and the screen. Duke, excellent. Rosanna, really?
So I just want to make sure I get this right. So on the transmitter microbit, I'm typing in 011.
Yes.
So I'm pressing A, B, B.
A
Is A 0?
A is 0. Well, A switches between 0 and 1. So you want to on the first column, you want to hit A until you see a dot. And
You
then
want to
hit
hit A until you see a dot.
and then hit B to do enter. Okay, so
So B is enter.
yeah.
Okay. Okay,
And-
thank you.
Oh, whoops. Let's see, I was moving the wrong thing around here. Okay, yeah, so it goes like this. So we're gonna hit
A.
we're gonna hit A until I see a dot, and then hit B to accept it. And then for the second column, we want a line for 1. So you hit A again to toggle to a
Okay.
line, and then hit B to accept that. And then
Got it.
automatically your next line appears as a 1. So now this is what 011 looks like, 1 dot and then 2 full lines. When that's good, then just hit the B one more time and you should see a check mark.
I got it. Thank you so
Perfect.
much for that explanation.
Yes, glad I could do it. I'm sure you're not the only one who needed that too. So thanks for speaking up. Now here is one to put in your transmitter microbit, and then check your terminal. See if this fits in the chat. Nope, won't fit in the chat. Okay, so I have to give you the web page of this one. And again, just put this in the transmitter microbit, and then it will display an arrow for a button you can use to start. It'll point it. I think it points at the A button to start the brute force attack. Bear with me just a second. So I'm going to put this in the transmitter here.
Okay.
And then send to microbit. Now what's going to happen is it'll point at the A key, and then we're not going to do anything to our vault that we're opening remotely right now. And but when you hit the A key, make sure to do show serial, because you'll be able to see the serial version of it, as well as it's trying the different combinations here. So here I go. I'm going to hit the A key, and we'll see that it starts with 000, and it got denied, and then 001, 010, and finally at 011, we get access granted. And we also have a nice little lesson on how counting in binary works. All right, so that is the beginning of brute force attacks. We'll try to do a couple more examples from brute force on Friday. We'll also be looking at one of my favorites is the malformed packet attack. We'll look at teacher resources, and we'll look at, let me get back to my slide. Okay, so yeah, we'll talk about cyber.org's educator resources, Parallax's educator resources. We'll do a little bit more on brute force, a couple examples from malformed packets. a few fun Cyberbot robot demos that I hope you like. And upcoming workshops, how to purchase microbits, cyberbots, etc. And any kind of Q&A and wrap up. That's the plan for Friday. For homework, all you want to do is you might receive a letter from like this, an email like this from learn.parallax.com if you've not been, if this might come in addition to the email that Stephanie sends out. And so follow the link and just follow the instructions in noreply.parallax.com email. And then Stephanie will have some instructions too. So follow those if you are not yet signed up for an educator account on learn.parallax.com. That's what you'll need to be able to access the resources that I'll be showing you on Friday. And then also go to cyber.org and hit the sign up link, I think it is. Yeah, the sign up link. Or just make sure you can log in if you've already signed up with cyber.org. And those are just your two homeworks. I'll send that out in an email as well. We'll send you the temporary video link, and then that'll get replaced by a YouTube link. And we'll see you all Friday at 3 p.m. Pacific time, 4 Mountain, 5 Central, or 6 Eastern. Okay, well, thanks for coming. For those of you who want to hang around and either get some tech support or if you have extra questions, if you have more middle school ideas or concerns, I'd love to hear from you. And aside from that, looking forward to seeing you again on Friday. Please do come. We take attendance, and if you make it all 3 days, you get a shiny certificate. Great. So anyway, and also feel free to email me, reply to any of the emails that have been coming out if you have additional questions that you want to cover offline at another time. Okay, well, great to see you all, and we'll look forward to seeing you again on Friday. Thanks a lot.